Hello guys, let's solve some questions from circular motions, some practice questions. Let's start with the first question. A particle revolving in a circular path completes first one third of circumference in 2 seconds, while next one third in 1 second. Calculate its average angular velocity. Fine. Let's try drawing a circle. And he's saying that one third of circumference means total circumference of circle is 2 pi r. 2 pi r, but it's talk about revolutions. If I talk in terms of angle, let us take this as a reference line, and total angle is 2 pi. In 2 pi, one third part will be 2 pi by 3. Okay, now so you can see 2 pi by 3 is nothing but 120 degrees. So in first 2 seconds, let's say this is t equal to 0 second and this is t equal to 2 seconds. In first 2 seconds, he covered 2 pi by 3 radians. Okay, and next you can say that while next one third in 1 second, again next 120 degrees, so it will be something like this. This is also 120 degrees, so I can say 2 pi by 3. If it is 2 seconds, so it is taking 1 second time, so it will be 3 seconds. Yeah, time interval will be 1 second. So here time interval t1 I'll take 2 seconds, and here time interval t2 equal to 1 second. 1 second. In the first 2 seconds is covering 2 pi by 3. In second 1 second is covering 2 pi by 3. He's asking us to calculate the average angular velocity. Let's calculate. Formula: omega average total angular displacement divided by total time taken. And please observe here we're having theta 1, theta 2. Theta 1 is 2 pi by 3. Even theta 2 is also 2 pi by 3. So I can say theta 1 plus theta 2 divided by total time t1 plus t2. So theta 1 is 2 pi by 3. Theta 2 is also what? 2 pi by 3. Divide by 2 seconds plus 1 second, it will become 3 seconds. So numerator 2 pi by 3 plus 2 pi by 3, it will be 4 pi by 3 by 3. 4 pi by 3 by 3. Totally it will become 4 pi by 9. 4 pi by 9 radian per second. So the final answer will be 4 pi by 9 radians per second for the first question. Let's move to the second question. Now please observe this question. The length of a second's hand in a stopwatch is 3 centimeter. The angular velocity and linear velocity of the tip. Very simple question. So actually he is indirectly providing radius value. Okay, now this radius value is 3 centimeter. 3 centimeter. Second's hand, by the way. He is asking us to calculate what is the linear v value and what is angular omega value. So one formula which I know for v will be r omega. For calculating v, r omega, r is given, omega we have to calculate. And for calculating omega, we have one formula which is 2 pi by t. 2 pi by time period. Now please observe how to calculate this omega. Omega equals to 2 pi by capital T means in one revolution, this second's hand, you can see that it will cover 1 minute. It will cover 1 minute. Okay, na? So it will cover 1 minute. Something like this, it will travel, it will cover 1 minute in one capital T. So 1 minute. So 2 pi, 1 minute means 60 seconds. Okay, so finally my omega value will be 2 pi by 60 radians per second. If you want, you can simplify this also, pi by 30, so on. I'm just leaving as it is, omega equal to 2 pi by 60. Let's calculate linear velocity v now. V equals to r into omega, where r is 3 centimeter, we convert into meters by multiplying 10 to the power of minus 2, and omega value will be 2 pi by 60. Let's calculate V. So 3 2s is 6 into pi 10 to the power of minus 2 by 60. You can cancel the 6 and 60. So finally V equals to pi by 10 into 10 to the power of minus 2. Okay, meter per seconds. If you want, you can simplify this writing pi as 22 by 7 or 3.14. You can still simplify this. I'm leaving as it is. Let's move to the next numerical. Okay, the equation for the displacement of a particle moves on a circular path is given by theta as a function of time, providing something like 2t power 3 plus 0.5. If theta is in radians and t is in seconds, then angular velocity of the particle after 2 seconds from its start. So if I want to calculate omega, because it's asking angular velocity, the relation between omega and theta is very simple. Omega is equals to the theta by dt. So we have to differentiate this given function. Let me differentiate this. So 2 into differentiation of t cube will be 3t square, and differentiation of constant 0.5 will be 0. Finally, I'm getting 6t square, and is asking exactly at 2 seconds. Just replace in place of t2 value. So omega equals to 6 into 2 square. So I'm getting 24 radians per second. This is the required answer. Okay. So let's move to the next question. Okay, an aircraft takes a turn along circular path, radius 1500 meters. If linear speed of aircraft is 300 meter per second, find its angular speed, time taken by its completing 1/5 of the circular path. Very simple question. Let me write down the given data first. So is giving an aircraft takes a turn of circular path, radius. I can take radius value r, 1500 meters. And linear velocity means v, which is given as 300 meter per second. Find its angular speed. He's asking us to calculate omega, and also what? He's asking us to calculate time. It's not time period. Time for completion of 1/5 of circular path. Circular path means circumference, which is 2 pi r. 2 pi r, but he is talking only 1/5 of it. I'll say 1/5 of 2 pi r. So we need to calculate the time for 1/5 of 2 pi r. Let me start the question. So first part is calculating omega. Omega is very easy. Let us directly use the formula v equals to r times of omega. Now here v is given 300 meter per second and r is 1500 into omega. So omega will be equals to 300 by 1500. So I can cancel 0 zeros. I'll end up with 1 by 5 or 0.2 radians per second. So omega is 0.2 radians per second. Let me calculate time also. So while calculating time, see if it is giving total time period, then definitely I'll use the 2 pi by omega formula. But here I cannot use 2 pi by omega. Please see, he is talking about only 1/5 of 2 pi r. So I'll just use this formula. Speed equal distance by time. Now I can use the same formula here. Speed equals to distance divided by time. So I need to calculate time here. So by the distance will be 1/5 of 2 pi r divided by t. And speed, though we know, speed is given in the question, which is 300 meter per second. So let me write that value here. So 300 equals to 1/5 of 2 into pi into radius is 1500 meters divided by time. Okay, now let me cancel this 5 and 1500. I'll be getting 300. Okay, and I'll just transpose this t to LHS side and 300 to RHS side. So 2 pi into 300 divided by 300. I can cancel 300. So finally I'm getting t equals to 2 pi seconds. Okay, so this is how you can solve this question. Let's move to the next numerical part, or next numerical. Okay, let's see what he is asking. Shaft of motor rotates at a constant angular velocity, so 3000 rpm. The radian it has turned in 1 second will be how much? Okay, so first of all, radian means theta. He's asking us to calculate theta in 1 second. The formula for theta will be theta equals to omega into t. Omega into t. So why I'm using this formula, like just like s equal to ut plus half a t square, I can even use theta equals to omega t plus half alpha t square, because he's saying angular speed is constant. This alpha will be 0, so this part will not come. So theta is equals to omega into t. Okay, now so here theta and omega both are same. T equal to 1 seconds. So I have to calculate omega. But if you see clearly here, this RPM indicates frequency. Let me convert into first RPS, rotations per second. So I just have to divide with 60. Now it will become RPS. I can cancel this too. So I'm getting frequency equal to 50 RPS. And the relation between omega, angular frequency, and frequency, we know it is simply 2 pi into small f. Okay, and here 2 pi into small f is 50. So finally I'm getting 100 pi as the answer. Okay, so this is the final answer. Let me move to the next question. So you can see an automobile takes U-turn in 4 seconds, then its average angular velocity is. Okay, first let me draw that U-shaped structure. If it is taking a U-shaped structure like this, it is asking average angular velocity. So average angular velocity will be equal to total angular displacement divided by total time. So if I talk about the total angular displacement, you can clearly see it is nothing but what? Pi. And the total time is given as 4. Very simple question. Pi by 4 radians per second. That's it. Let me move forward. So he's asking the ratio of angular speed of minute hand to that of second hand. It's not hand, it's hand. Is. So I can directly write the formula omega equals to 2 pi by t is the formula I'm going to use now. So here I just have to write omega minute hand. So I can say 2 pi by t minute. Okay. Now, so for one revolution in 1 minute, minute hand will cover 60 into 60 seconds. 60 into 60 seconds. One revolution of minute hand will be 1 hour. In 1 hour, you can see that I'm converting into 1 hour means 60 minutes. 60 minutes means 1 minute will be 60 seconds. So I can convert like this. Let's talk about omega seconds hand. So this is also 2 pi by t second. Okay. So definitely here t second means in one revolution it will complete 60 seconds hand. I can write 2 pi by 60 second. He is just asking us to calculate omega minute hand by omega seconds hand. Let's divide this two. When I divide this to 2 pi by 60 into 60 divide by 2 pi by 60. So 2 pi cancel, 160 will get cancelled. Finally I'm getting 1 by 60 ratio. So t omega minimum by omega second will be 1 by 60 is the final answer. Okay, let's move to next question. Okay, so disk starts from rest, fine, and gains an angular acceleration given by this much. Calculate its angular velocity after 2 seconds. Okay, so from the question we can understand that alpha is not constant because he is giving something like this is t square, Nana. So 3t minus t square, and is asking us to calculate its angular velocity after 2 seconds. So here when alpha is variable, definitely the relation between alpha omega we can write like this. Alpha is equals to d omega by dt. So alpha dt d omega. Now I have to integrate both the sides. So here I'll start with initial angular momentum is 0 because it starts from rest, and then it will reaches to some omega value. We need to calculate this omega, and time is 0 seconds to 2 seconds. Okay, let's integrate now. Alpha is given as 0 to 2, 3t minus t square whole dt, and this integration of d omega will be omega, and you just have to keep the limits 0 to omega. Now this is how much? 3 by 2 t square minus t cube by 3. We have to keep the limits 2 to 0, and after keeping limits omega, you'll get omega minus 0. Now first keep the 2 value. So it will become 3 by 2, 2 square minus 2 cube by 3 is equals to omega. This is how much you can get? 1, 2 will cancel here. It will become 6 minus 8 by 3. 6 minus 8 by 3. If you simplify this, 18 minus 8 by 3. Finally, I'm getting 10 by 3. So my omega value will be 10 by 3 radians per second at 2 seconds. So yes, answer is 10 by 3 radians per second. Let's move to the next numerical. You can say the frequency of particle performing circular motion changes from 60 rpm to 180 rpm in 20 seconds. Is asking angular acceleration. Very simple question. So angular acceleration will be equal to omega final minus omega initial divided by time. Because it's given in the frequencies rpm, by the way, I can write like 2 pi into n final minus 2 pi n initial divided by 20 seconds. Alpha equals to, I can take 2 pi common, and this is 180 minus 60 rpm. By the way, we have to convert into rps. To convert into rps, we need to divide 60. So, and then 20 is already there. Now please observe what you can do. Alpha equals to 2 pi, this is how much? 120 divided by, so this is 2's, and you can see that finally I'm getting 4 pi by 20. So you can cancel this 2 also. Finally alpha I'm getting as pi by 5 radians per second square. Fine. Let's move to next question. So please observe. Again, he has given theta as a function of t. I think he's asking angular acceleration. We can do it easily. So theta given, it is square now. It is also cube. So let's differentiate this. So this is will give provide omega. So I'm getting a plus 2bt 3ct square. Calculate alpha differentiating omega one more time. So it will become 2b plus 6ct. He's asking at 3 seconds. Just replace in place of t this 3 value. So finally alpha will be 2b plus 3 6 18 18c. So this is the final answer. Units radian per second square. Let's solve one J-Men's question also. It is 60 degrees, by the way. A particle is moving along a circular path with a constant speed. So it's talking about uniform circular motion. So v equal to 10 meter per second. What is the magnitude of the change in velocity of the particle when it moves through an angle 60 around the center of the circle? Okay. So if I start with this velocity v, and here if it is taken as some velocity, initial point is, and this let us take 60 degrees. So here this also v, constant na speed. So when I try joining these two velocity vectors, we can see the angle between them is 60 degrees. Okay, and here I'm finding the change delta v. So when I find out delta v, the value will be root over v square plus v square minus 2v square cos 60. Okay, so in practice we'll already learn this formula, like whenever we're talking about change in velocities. Directly when I solve this also, I'll end up with the formula 2v sine theta by 2. You can simplify this, you will get the same answer. So directly I can keep the value now. V will be 10 sine 60 by 2 is sine 30, and this sine 30 is 1 by 2, so sine 30 and 2 will get cancelled. Only the change delta V will be 10 meter per second. 10 meter per second. Yes. Answer is 10 meter per second. Okay, one more question. The same question only, correct? So we're done with this part. Let me move to the next question. Cyclist is riding with a speed of 18 kmph. As he approaches the circular turn on the road of radius 25 root 2, he applies brake, which reduces the speed at a constant rate of 0.5 meter per second every second. Okay, determine the magnitude of net acceleration. Okay, so we can see that it is definitely not UCM, meaning it is not uniform circular motion, because value is keep on changing for velocity, and value changes, tangential acceleration component will come into the picture. So definitely is referring or inferring to non-uniform circular motion only, where a net value will be root over a tangential square plus a centripetal over a normal square. So we need to calculate ATAC. From a question we can understand that when he applies brake, reduce his speed at a constant rate of 0.5 meter per second every second. He is talking about tangential. So minus dv by dt. Speed is getting reduced, that's why minus dv by dt, and this value is given as minus 0.5 meter per second. It is nothing but minus 0.5 meter per second square. So he's given already the value of tangential acceleration 0.5 meter per second square. Let me talk about centripetal acceleration. Formula is v square by r. If you say v square, he has given kilometer per hour. First of all, let me convert into v equal to 18 kmph. I have to convert into meter per second by multiplying 5 by 18. It will be a 5 meter per second. So it will become 5 square divided by radius to 25 root 2. Okay, so 25 by 25 root 2. Finally, I'm getting 1 by root 2 meter per second square. So finally, I got a tangential, a centripetal. Let me keep it in this formula, net acceleration. A net is equals to, see, just minus 0.5 now I can write like minus 1 by 2. So minus 1 by 2 whole square plus 1 by root 2 whole square. So I'll be getting 1 by 4 plus 1 by 2 square root. It will become 3 by 4 square root. Finally, root 3 by 2. Root 3 by 2. Even if it's asking decimal, you can do it. Root 3 is nothing but 1.7. 1.7 by 2. 1.7 is approximately 1.8. Somewhere around 0.88986, something like that, we can able to get the answer. So I'm just leaving as it is. A net will be root 3 by 2 meter per second square. Okay, so that's it for the day. I have solved some practice questions of circular motion. I'm gonna add previous questions of mains and also previous questions of advanced also slowly. So this for the day. We'll meet in the next video. Thank you very much.